Pre-AICE chemistry students, this is a PowerPoint/lecture on balancing chemical equations. This will be a part of section 2 and chapter 4 in your text. And let's get started. So why do we need to balance equations? One, it quantifies chemical work. So reactions occur with reactants and they make new products, either give off energy or you need absorb energy. We'll talk about that later. But atoms of each element are equal on both sides, so it quantifies a reaction. And also is the law of conservation of mass. So no mass is lost. It can be transferred or converted into light or heat, but no mass is lost. So the mass you have on the left, the reactant side, on the right, the product side, should be the same. So we'll get to this when we get into stoichiometry. So how to balance? So first you have to make sure you count the atoms on both sides of the reaction. So this is the initial counting of the reaction. We use coefficients for the multiples of the atoms and molecules, so we're basically adding molecules or atoms to each side to make sure they equal on both sides. We recount and repeat if needed to make sure that the atoms of the reactants are equal to the atoms of the products of each individual element. So let's get to it. So we have mercury oxide, and it decomposes into mercury and oxygen gas. So first step, we have to write our elements out. We have mercury and oxygen, that's it. And on the left side, the reactant side, there's one mercury and there's one oxygen. And on the right side, there is one mercury as well. And now there are two oxygen atoms because oxygen is always diatomic when it's by themselves. So it's not balanced. You can see that mercury is balanced, both 1 and 1, but oxygen is not. It's 1 and 2 on the product. So to balance oxygen, obviously we need to balance oxygen. We use coefficients, numbers in front. So we have to multiply the 1 by a number to get 2, which is 2. 2 times 1 is 2. So we put a 2 in front of the mercury oxide because that's where oxygen is. And that changes oxygen to 2, but also changes mercury to 2 as well because it is a compound of both mercury and oxygen. So if you change one, both of them have to change. So oxygen is balanced, but mercury is not. So we have to go to the product side and change mercury. And again, you have to make sure it gets to the number 2, which would be the coefficient 2, because 2 times 1 is 2, and you have now 2 mercuries. So you can see that both elements are balanced, that both are equal, 2 mercuries and 2 oxygens. They do not always have to be the same number, but they do have to be the same for both elements, or for the one element, sorry. Alright, let's do it again. So our elements are nitrogen and hydrogen. And on the reaction side, there's 2 for both nitrogen and oxygen. Again, because they're both diatomic, so they always have to have 2 of the atoms. And on the product side, there's one nitrogen and 3 hydrogens. So both of them are not balanced, so it's really your choice on what you want to balance. I'm going to go with hydrogen first because it's a little more complicated because you have a multiple of 2 and 3 instead of 2 and 1. So on the reactant side, we put a 3 in front of hydrogen because it is a multiple of 6. So we need to multiply the 3 by 2, and you get 6 hydrogens. So on the product side, we need to multiply the 3 by 2. So you put a 2 in front of the coefficient, and you get 6 hydrogens. That also changes nitrogen because nitrogen is with NH3, or with hydrogen on the product side in NH3, which is ammonia. So that nitrogen also has to get multiplied by 2. 2 times 1 is 2, and now you have both elements balanced. Notice there's 2 nitrogens on the product side, or reactant and product side, and there's 6 hydrogens on the reactant and product side. Boom. Okay, let's do it again. We have barium, we have sulfur, we have oxygen, and we have carbon. So 4 elements, a little more complicated, but same steps apply. We count up each element on the reactants and products. There's 1 barium, 1 sulfur, 4 oxygens, and 1 carbon. And on the product side, they're all 1s. Okay, so pretty simple. Only thing that you need to look at is oxygen, because that's the one that's not balanced. So we have to make sure that 1 turns into a 4 by multiplying by 4. 4 times 1 is 4. That is 4 carbons. Oxygen, sorry. It also changes carbon because oxygen is with carbon and carbon monoxide, CO. So that carbon changes to a 4 as well. So barium's still balanced, sulfur's still balanced, oxygen's now balanced, but now carbon is not. So on the reactant side, we have to make sure we multiply the 1 by 4, and you get now 4 carbons. So now as everything is equal, and you did a fantastic job. Alright, so these are some practice ones for you, A and B. You can pause the video to do some practice, and I'll give you a few minutes to pause that. And when you continue, you can check your answers by continuing the video. So you should get 2 irons and 2 FeOs. And then for B, you should get 2 Fe, 3 chlorines, and 2 FeCl3s. Alright, we're going to do balancing combustion reactions. So these are specific reactions that make CO2 and water, and it's usually a hydrocarbon, which is the carbon and hydrogen compound. In this case, we have C2H6, which is called ethane, close to ethanol, but it's just ethane. And it reacts with oxygen, which is the definition of combustion, and you always make the byproducts of CO2 and water. So we have C, we have H, and we have O on both sides of the equation, and on the reactant side we have 2 6 hydrogens and 2 oxygens. Again, oxygen is diatomic, so that's why there's always 2 O's when it's by itself. And on the product side, we have 1 carbon, 2 hydrogens, and be careful, we have 3 oxygens. Oxygens on both products of CO2 and water. So the first key to the combustion reaction is to leave oxygen to the end. Since it is on both sides of the on both products, CO2 and water, it's easier to use that to the end. So if we do hydrogen, we put a 3 in front of water, and that makes 3 times 2 turns into a 6, so that's good. And that changes oxygen to also a change, but remember you're adding 2 from CO2 and you have 3 from water, and that gives you 5 oxygens. Now this is where it gets a little tricky. If you notice, the reactant side has O2, and there's 2 oxygens. So whatever number I multiply this by, it's always going to come out even. If I put a 3 there, 3 times 2 is 6. If I put a 5 there, 5 times 2 is 10. Those are even numbers. So I can never get, I always have to make sure that the oxygen is always even. So that's step number 2. The coefficient for water must be even. Okay, so that means whatever number I multiply the even number by oxygen, it will come out even. So that 3 needs to turn into a 6, because 6 is even, so you basically multiply by 2. That changes hydrogen to 12, and that changes oxygen to 6. So now 6 is even, so we can move on further to balance out the equation. So now that we have 12 hydrogens, we need to multiply the reactant side by 2, and that changes hydrogens to 12. 2 times 12 is, or 2 times 6 is 12. And that also changes carbon to 4, because 2 times 2. Going back to the product side, we have hydrogens balanced, but now our carbon is not. So we need to change the carbon to 4 because there's 4 on the reactant side. So 4 times 1 is 4, and that gives us 4 carbons. So carbon's balanced, hydrogen's balanced, now oxygen's not. So oxygen on the product side is in 2 spots. We get 8 from the CO2 and we get 6 from the water, so 8 plus 6 gives us 14. So we have to make sure the reactant side gets to 14. So what number times 2 gives us 14, and that would be 7. 7 times 2 is 14. So we are now balanced of a combustion reaction. 4 carbons, 12 hydrogens, and 14 oxygens. Again, here's your turn to balance out the combustion reactions. We have A, methane combusting with oxygen, and then we have B, butane combusting with oxygen. You can pause it now to work on it. And here are your answers. For A, we have 1 methane, 2 oxygens makes 1 CO2 and 2 waters. And then for B, we have 2 of the C4H10, 13 oxygens, 8 carbon dioxides, and 10 waters. Alright, last final example. This is a polyatomic balance equation. Polyatomic means they have multiple atoms together. So for example, aluminum hydroxide is a polyatomic because it has hydroxide. H2SO4 has SO4. So they are polyatomics. So the key things about polyatomic is that you treat the polyatomic as one whole unit if it doesn't change. So for example, OH is a polyatomic, but there's no OH on the product side, so it does change. SO4 is on the reactant side, and SO4 is on the product side, so that does not change. So you want to treat it as a whole unit if it doesn't change. So we have aluminum, we have oxygen, we have hydrogen, and then we have SO4 as one whole unit. So it gets a little tricky here. Step 2, we gotta balance it. We have to count the atoms of 1 aluminum, 3 oxygens, 5 hydrogens, because 3 comes from the OH, and then 2 from the H2SO4, and there's 1 SO4. And then on the product side, we have 2 aluminums, 3 SO4s, because there's a parentheses with a 3 outside the SO4, 2 hydrogens, and 1 oxygen. So to balance it, I always like to balance the polyatomic first. Keeps the complexity, the complex one done first. So you can see that there's 1 on the reactant side, 3 on the product side, so we need to make that SO4 into a 3. So we have to put a 3 in front of where SO4 is on the reactant side, which is where H2SO4 is. So that turns into a 3, and that changes SO4 into 3. It also changes hydrogen to 6 of them, plus the other 3 from aluminum hydroxide, and you get 9 hydrogens. So next up is aluminum. We gotta put a 2 in front of Al because there's only 1 there and we need 2 of them. So that changes aluminum to 2. Now it also changes oxygen and hydrogen because there's OH. Hydrogen turns into a 12 because there's 6 on the AlOH3 and there's 6 from the H2SO4. And then there are now 6 oxygens because 2 times 3 is 6. So we go to the product side. Aluminum and SO4 are good, so we just need to change water. So what number times 2 gives us 12, and that would be 6. So that gives us 12 hydrogens and also gives us 6 oxygens. So everything's balanced with the correct number of elements, or number of elements on both sides. Alright, so your next assignment is you have a complete balancing reaction log in the Google Classroom. It's under Unit 2, Reactions, Balancing Reaction folder, and then the assignment is Balancing Reaction log. There's directions for that as well. If you need more tutorial links, they are available under the balancing tutorials, also in the same folder of unit of balancing reaction folder.